Hey everybody, welcome back to the second week of presentations. Hope everything's going well. First week I thought went pretty well. I don't know about you. If I've learned one thing, it's that, of all these new job responsibilities I have, video editing is super far down my list of things I enjoy. We got there, but video editing, not something I'm having fun with. Anyway, so we're here. So we've got 7 presentations tonight. Again, like last week, I'll take a break somewhere in the middle. That being said, I don't think I have anything else. Let's get started. Hear about Bootstrap.
Hello everyone, my name is Junho, I'm in Group 4, and today we will be presenting Bootstrap. Bootstrap is a front-end framework that was created by Twitter in 2011, and it remains the most popular front-end framework in 2020. It has an integrated grid system, which makes your website responsive to different screen sizes, which in turn makes developing for mobiles very easy. It has a very easy installation step, which we will demonstrate in just a moment. And it is open source, so if you need to overwrite a certain feature in Bootstrap, you are able to do so. Our presentation will cover the 4 topics in Bootstrap that we have found to be important, those being layout, content, components, and utilities. And now we will jump straight to a very quick installation demo, which will show you how easy it is to get started with Bootstrap. Although there are several ways to get started with Bootstrap, the quickest way by far is to simply copy-paste the link that is provided by Bootstrap that contains all the CSS files that you need to get started before all the other style sheets in your HTML file. I have done that here in this highlighted line, and to check that it worked, we go to our index.html. And you see that in the upper left corner here that the text has turned green. And that is because we are using one of the color utilities classes that comes with Bootstrap.
I will be talking about how web content can be laid out across a web page using Bootstrap. Bootstrap has many ways to allow developers to organize their web content. The main layout components are the containers and the grid system, consisting of columns and rows, both of which are included within an HTML file's div tags using a class name, all of which have varying classes to allow developers to customize the layout of their web content based on their needs. Some of the customization can include being able to choose the width of your web content in response to the various screen sizes. Bootstrap is very easy to utilize with minimal or no CSS required. All the classes are defined by Bootstrap themselves, and all CSS is also done by Bootstrap. It can be done with just an HTML file using the div tags and the class names. For the grid system, it's made up of rows and columns. You can have as many rows as desired, and each row is made up of columns, which together add up to 12 column spaces. And as you can see within this little diagram, you can mix and match them based on desired preference. There are various customization possibilities for rows and columns, but for columns, one of the more common ones is you can change the responsiveness of the width for various screen sizes, and there are other possibilities. For the rows and columns, they're included within the HTML file using div tags and a class name, either row or col, and the column classes has to be placed within the row classes. For the column classes, the most standard class is col, but there are numerous other col classes that can be used to fit the developer's customization needs. The standard format for the column classes is col dash, and then the width of the column in response to the screen size dash, and then the number of column spaces that this col class takes up. If certain attributes aren't specified, then Bootstrap will automatically adjust those attributes using default values. The only real required column class is just col. The others are optional. There are many other customization possibilities, such as vertical or horizontal misalignment. You can reorder the columns within one row, and you can also do custom responsive padding, which Bootstrap calls gutters. And there's also nested columns as well as rows, and you can automatically adjust the column spacing based on the web content that resides within the col class. The containers, they are just wrappers for the grid elements. They make adjusting groups of content much easier just by putting all the web content within a container, and then you can adjust it any way you want, such as the width in response to the screen size, or you can either center, put it left, right. It makes it much easier than having to manually change the class names for each of the rows and columns. There are multiple container classes that can be used based on developer preference, and they utilize various breakpoints which are defined using media queries. And while they're useful for creating responsive web pages, they're not required. It's completely up to the developer on how they want to use the containers. Multiple containers are possible for different sections of the web page, as well as different web content. So I'm just going to have a quick demo on showing the responsiveness of the containers as well as the column classes. This is the demo page I set up. It uses the same HTML file that I had screenshots of on the slides. I'm just going to be focusing on this column, defined by col-md-8. For the responsiveness of the width, you can use either small, medium, large, or extra large. That usually is corresponding to the screen size. So I'm just going to be using MD for medium. Now, this is what it would look like normally as I change the window size. It eventually gets stretched out all the way across the entire width of the parent element, in this case the container. So now moving on to containers. I have two containers, but we'll be focusing on this one first. I just have the standard container class. Now we want to focus on the max width. It's 1140 pixels. But as I change it, it hits a breakpoint, and now it gets shifted to 960 and so on. Eventually it'll hit a certain breakpoint where then the width of the container will be stretched across the entirety of the web parent element, in this case the body. And both the container classes as well as the column classes, they use the same breakpoints. So you can use -XL for extra large, and then as you can see, it's 1140 pixels, but once it passes one breakpoint, eventually it gets set to 100%, so it's stretched across the entire body. So aside from the containers that use the breakpoints, there is another container class called container fluid, where the width of the container, no matter what the screen size is, it'll always be 100%. So no matter what, it'll always be stretched across the entire body. So that is it for layouts. Next, we'll be talking about contents.
A collection of element-specific CSS changes in a single file kickstart Bootstrap to provide an elegant, consistent, and simple baseline to build upon. Providing many HTML elements with optionated styles using only element selectors. Additional styling is done only with classes. Content is a key to the modern UI. Bootstrap content mainly consists of the following 5 areas support: typography, headings, body, text, list, code, displaying inline and multi-line blocks of code, image, opting images into responsive behavior, table, opting in style of tables, figure, displaying related images and text with a figure component. Here is an example of a simple personal tag block. Let's try to make the title much bigger. Without Bootstrap, H1 is the biggest tag you can have for a font size. Providing Bootstrap display classes, you can achieve much bigger fonts without any CSS. And similarly, p tag, adding small classes into p tag will make the paragraph font much smaller. With black quote tag's help, it's very easy for you to structure a text looking like this. And the cited footer is also very convenient to construct a citation. Code block. It's very normal to provide formula or code in the content with pre-code tag. You only need to focus on the text, on the content. Put the content into the pre-code tag. You will have everything just align correctly, and no need to worry about the other styles. Speaking of images, the biggest problem for image is the responsive. Nowadays, people are using mobile and desktop, different screen sizes. With image fluid class, it's very easy to make your image responsive to most of the screen size. Also, with image thumbnail class, it will automatically default create 1 pixel border for you. And with figure tag, make it very convenient for people want to add the caption for the images. Table is also highly used in modern UI and modern web and mobile application. With the help of Bootstrap table tag, it's very simple to make the table responsive. And also, Bootstrap provides customization by adding different table-related classes. For example, to make the first table stripped, you just need to add the table stripped, and to change the background of the table, you only need to give this class, table dark class, and everything will just simply change in the right way.
Some examples that would be components of a website are navigation bars, forms, buttons, and lists. However, with vanilla HTML, CSS, or JavaScript, each components have their own intricacies and considerations when we implement them. With Bootstrap components, we can easily get set up and have our website up and running. To demonstrate how easy it is to set up a website with just components alone, we will go through a quick demo. To get our components, we'll quickly navigate to Bootstrap's documentation. Here is a navigation bar. We'll copy, paste. Next, we will have our carousel. Copy. Currently, our carousel is broken because it has no reference images. We will quickly correct that. Next is cards. Let's make a row of these. Currently, these cards are referencing an image, but we don't have any, so we'll just remove them. Lastly, our form. And paste. So here, we have a pretty nice looking website. So if we had tried to do this without any library and do everything ourselves, it would have taken a lot more time. So now we have a point of reference and something we can easily build off of and customize. On the plus, with Bootstrap, everything on the site looks cohesive. Some components have JavaScript capabilities, but you don't have to write any of it. For instance, this carousel. Next, because these components were made with Bootstrap classes, they are also made to be mobile friendly. As a benefit, we don't really need to write any media queries whatsoever. Next is documentation. A library's features are as good as their documentation on how to use them. For instance, let's take a look at spinners. It gives a good description of what it is, what it does, and it also shows me different variations, along with the HTML. And this applies to all of Bootstrap's components. With a good understanding of the tools that you are working with, you will easily be able to incorporate Bootstrap into your website.
Hello everyone, welcome to the utilities section of the presentation. In this section, we will see a few examples that demonstrate how Bootstrap utilities classes can help 1. Make stylistic changes directly from HTML, and 2. Make your websites more responsive to different screen sizes. If I could direct your attention to the header on the top of the page here. Before, in one of our previous assignments, to make stylistic changes to HTML, we had to modify them in the CSS file, whereas with Bootstrap utilities, we can simply write that code directly on the HTML. So for padding, I can write in class P for padding, L for on the left side, 2 for the 2 REM units that I would like for the padding, and since these are REM units, they would scale. Same thing here, except that we're doing PR-2 for padding on the right side, background dark, text white, text center, and there we go for the header. So no more going through a CSS file for simple style changes. It can all be done from the comfort of your HTML, which is great. Now moving on to a couple other examples that show how Bootstrap utilities classes can make your website more responsive. The first one is embeddings with preset aspect ratios that respond to your screen size. So if you look at this video here, as we make the window progressively larger, you can see that it preserves its aspect ratio very nicely. And the aspect ratio itself can be changed pretty. For example, we would change this line of code. Right now we are on 16:9. We can make it 21:9 by simply replacing 16 with 21 over here. We refresh the page, and there we go. Our final example would be if you look at this paragraph on the bottom. As we make the window progressively smaller, there we go, it stops displaying, and we come back up, it starts displaying again. Bootstrap supports displaying content only within a certain screen size. So if you have content for a tablet that you might not want to display for, let's say, a smartphone, and vice versa, instead of having 2 HTMLs with different content for both, with Bootstrap utilities, you can simply have one HTML and simply choose which content that you want to display, that you would like to be displayed on a certain screen size. And the code to do that is over here. D-none refers to hide for all. D-sm-block refers to for all screen sizes smaller than an SM. And SM is just one of the preset breakpoints that come with Bootstrap that correspond roughly with real world sizes. So SM would roughly be an average smartphone, whereas XS, for example, would be an extra small smartphone. I tried holding my smartphone over the browser as it goes in and out, and SM is actually a slightly wider than my phone, but we'll just let that go. So, and this only touches the surface of what's available in Bootstrap utilities. I hope this section was helpful. Thank you for your time.
Let's do a quick recap, and for pros, it's easy to set up and mobile friendly from the beginning. It's also well documented with a low learning curve. It has all the tools you would need to develop a modern website and can be easily integrated with any backend framework. Although you can customize attributes of components, Bootstrap still has a certain way it wants things to look. So you sacrifice uniqueness if you want your website to stand out from the crowd. That concludes our Bootstrap presentation. Thanks for watching.
Hello, this is Ali from Group 9, and I'm here to talk to you about Ruby on Rails. Rails, I'm going to call Ruby on Rails Rails for short. Rails is a server-side web app framework. It's written in Ruby, and it's released under the MIT license. Importantly, that means it's free to use for commercial purposes. It isn't a copyleft license. And it's used in a lot of really popular sites, including Airbnb and GitHub. Additionally, it's influenced a lot of other web development tools, including Django and OutSystems and plenty of others. It includes features to help quickly create simple web pages. For example, it uses scaffolding to auto-generate views of database tables. If you have a table, for example, of students, and you just want to generate a quick, easy list of all of them, you go to the command line, you enter in some parameters, and it'll generate all the boilerplate for you. And you can take that boilerplate and start editing it to get exactly what you need. So getting to Hello World is really quick. Additionally, it includes WebRick, a built-in web server, Rake, a built-in build system, and SQLite, which is configured to use by default. So all these things together lets you get that web app going fairly quickly. Here are two key quotes about Ruby on Rails philosophy. Rails is designed to make programming web applications easier by making assumptions about what each developer needs to get started. It's on Rails, is basically what it's saying. Excuse the bad joke. Second quote here is, Ruby makes the assumption that there is a best way to do things, and it's designed to encourage that way, and in some cases to discourage alternatives. And that has both positives and negatives. The two guiding principles is don't repeat yourself. That's in a lot of software. Don't have 5 different implementations of the same thing all over your code. And additionally, the second thing is convention over configuration. What that means is that Rails chooses a reasonable default and a set of conventions that it feels are best. The pro to that is that there's a lot of documentation and support for the default options, but the con is, excuse my metaphor, if you go off track, and you get off that train, start walking, it's a lot more difficult to get where you need to go. It's it's inflexible. Okay, so Rails technically under the hood is a model view controller architecture, like a lot of other web tools. It calls its model the active record, and that's handles the business logic, connects to the database, all that. The action controller handles the user inputs and command routing, and the action view generates the HTML and everything else and sends it to the user. Ruby on Rails has generators that you can do through the command line to auto-generate boilerplate code. For example here, Rails generate model movie and title string description text generates a movie type. It creates a movies table in the database and generates several configuration files. See there, I made an assumption that your movie type is going to be in a movies table, and Rails does a lot of this sort of thing to make things quicker. Overall, so far, the pros for Ruby on Rails is that it's very capable. As you can see, it's used in a lot of big sites. It's very popular. There's a lot of support, a lot of documentation, and it's really quick to get started. The time to hello world as a metric is very fast, very low, right? Cons is that it's very opinionated. If you're used to doing things in a different way, you have to do a lot of, oh, I know how to do this, but I don't know how to do it the Rails way. So go to Google, read some Stack Overflow. Additionally, Ruby is not a very common language. It's not as popular as, say, Python for Django. So outside of Ruby on Rails, you're not really going to use much Ruby, as far as I know. And it runs on an interpreter, spelling mistake, by default, not interpolator, and that can have performance issues. There was a case where I believe it was Twitter was using Rails, and it had some performance issues, and they had to replace some components with Scala. And here are my works cited. Next, we're going to show you some technical demos going into more detail about Rails. Thank you.
Hello, my name is Jordan. I'm here to demo Hello World. First, we need to create our website with Rails new and then the name of our website. This takes about 30 seconds. Now that we've created a website, we can run it by going to the folder and doing Rails server. To verify that our website is running, we can go to the localhost. Now that we know our website is running, we can add Hello World. To do that, open a new command prompt and go to our folder and do Rails generate controller, and then the name of our controller, and then the name of our action method. Now that we've created it, we can go back to our browser and verify that it's there. We have created Hello World. So why was it so fast? Because convention over configuration. Rails has a set of default configurations that it uses. If we look at the URL, there's a pattern. Text is the name of our controller. Hello World is the name of our action method. Rails will then create a new instance of text and run the action method Hello World. Rails then looks for html.erb in apps/views and runs any embedded Ruby and then creates an HTML file to be displayed on the browser. Next is dynamic generation demo. I'm going to run a different website. This website, I can dynamically change the text according to the URL. As you can see here, the text changes according to the URL. So how is this possible? If we look at the code here, as you can see, we are grabbing the parameters and then sending it to the HTML. So then Rails can insert into here. Then we also need to route. So here we add this line here. And then this input is our parameter. And here we are telling Rails to use our text controller. And then our action method, Hello World. We are able to use the same HTML file for multiple things. This is one of the philosophies of Rails. Don't repeat yourself. A useful application for this is displaying user profiles. This concludes my demo.
So one feature that makes Rails stand out amongst other popular frameworks is how it manages and interacts with databases. So common functions such as creating, reading, updating, and deleting records in a database are simplified, as well as being able to edit database schemas and specify validation for input. In this demo, we'll take a look at how easy and flexible it is to set up a database with your Rails application and the different features that Rails provide. For example, we have created a simple blog application where users can create and submit articles. For this example, we will be creating a relational database called articles, which will have two attributes, title and text. So taking a quick look, you can see that we can create new articles with these title and text attributes, as well as edit them and delete them. So we will show how we were able to achieve this in Rails. So to create our articles table, we need to create a new resource, as we do in this line of code. This resource method is provided by Rails and is used to declare a standard REST resource. So once we add this, all of the standard RESTful actions are provided for our table. So to put it simply, a REST API is a type of API that uses endpoints to specify resources and uses HTTP methods such as get, post, put, and patch, as well as delete to perform some action on that resource. So once we have added a resource for our articles table, all those standard RESTful services are already created for us, and we can view them using the command Rails routes. So as you can see here, get, patch, put, delete, post, create articles, delete articles, update them, all those endpoints are already specified for us, and all we need to do now is to define them in our controller. So if we were to use one of those endpoints right now, say create article, we would get an error. In order to create a new article or perform any other function on it, we need a controller for that model. So to generate a new controller in Rails, we enter the command Rails generate controller. So I've shown down here. So once a controller is created, it is empty by default. So we need to add in our CRUD operations. So implementing the different CRUD operations are fairly similar in terms of what you need to specify. So we'll take a look at just one operation, the create method, which is here. So the create action needs to save data in our database. As you can see in this first line of code here, what's going on is every Rails model can be initialized with its respective attributes, which are automatically mapped to the respective database columns. So in the first line, that is what we're doing. The article.save is responsible for saving the model in the database. So it returns either true or false. So this is a Boolean expression. So if it is true, we will redirect to the article, we'll show the article that you created, else we'll stay on this create page and possibly display an error message. However, creating just this function is not enough. Rails has several security features that help you write secure applications. If you were to create an article with just this, you'd be shown an error, because Rails enforces this thing called strong parameters on controllers, meaning we need to tell Rails exactly which parameters are allowed into our controller actions. So do that by specifying this function, articles params, tells us we will only accept title and text attributes. So you may be wondering, what is the point of this? So suppose a request to the server was crafted to look like a new article, but it also included extra fields. These extra fields when put into our database can ruin our data or possibly our application. So it's a safety measure that Rails enforces. So in addition to specify what parameters we are accepting, we can also have some type of validation on those parameters. If you were to look at our model class, you can see that we're validating that the title is not null, so it is true. So the presence is true, it is there, and that it is at least 5 characters long. So if we were to go back and create an article that didn't meet this criteria, so there's 2 things we need to meet. It is not null and it's 5 characters long, we'll get an error message. And you can see that Rails provided this nice human readable error message for us. Two errors prohibited this article from being saved. Title can't be blank. Title is too short. Now I didn't explicitly mention these strings to be printed out. What I did was, when I'm displaying this HTML, if there are any errors, I'll print all of those out. So you can see that Rails prints out this nice human readable message for us. So you can see how simple it is to create a database in Rails.
Okay, I'm going to talk about debugging with Ruby on Rails. So the first one is debug and simple format. These are very basic debugging tools you can use. On the top left, you can see using debug, and on the top right, simple format. They both output the exact same output, and it just breaks down an object into YAML format, which is just a human readable format. And this can be done on any variable, object, or method. So if you'd like a better inspection of what variables, the current objects holding, you can use debug or simple format. Okay, the next one is puts, print, and p. So puts and prints are just basic debugging, print here or print tests, stuff we used to do or maybe still do. It's not a very effective method of debugging, but sometimes when you've been staring at the screen for a few hours in the lab, you get desperate. You insert these. So I just put this here to let you know you can still do that if you want to. The difference between puts and print is that puts adds a new line after each print off, and then print, it just continues printing on the existing line. The one we care about here is p. This is an actual debugging tool that we can use. It displays a raw version of the object similar to the debug method that we just talked about. And it's pretty easy to inject into your code here. So we can see from this little snippet of code, the second to last line, p book. So in this example, it'll just print the book object. But in general, it just displays a raw version of the object, so you can debug it. Okay, so now I'm going to talk about more advanced debugging tools. So these are various gems you can install onto Ruby on Rails. The first one is Web Console, and this one just opens a console on the current page. So you can use the command there, %console % with the in the brackets, or just use the console depending on what type of page is open, and it creates an interactive Ruby session on your browser. So this is helpful because while you're using it, while the console's open, you actually have access to all the variables and classes that were run beforehand, and it's just like a pure Ruby on Rails editor. So you can interact and change variables at that point where you stop the code, and you can use this to help debug. And then you can also, with the web console, go back through stack traces and see how different variables and methods, how variables were changed in each respective frame, and how if it's working properly or as you intended it to. So the next two I'm going to talk about are pry and bybug, and these are two debugging gems that share similarities because they're both just for debugging, but they do have some differences. So for pry, you just insert binding.pry anywhere into your code, and it acts as a line break and stops program execution. And then what it does is opens a pry terminal session. So this one is in the terminal versus web console. Was in a web page. Both pry and bybug are terminal. And then you can use commands like step, next, and continue to traverse through your code. So step, it goes forward one instruction and goes into method calls, whereas next you do not go into method calls but also step forward one instruction. And then continue, it'll just run until the next stop, whether that's your next binding that you've inserted or end of code or whatever. And then if you ever see unusual behavior happening as you're stepping through your code, you can use functions like where am I, and it shows the source code of the method you're currently in. So if you ever see something unusual, you can just immediately look at the source problem, so you can debug exactly where something went wrong. Okay, so now for bybug, it's very similar to pry, but instead of inserting binding.pry as your line break, you just insert bybug, or you can use the function break and then the line number, so like break 6, and it will add a breakpoint at line 6 of the current form you're looking at. Bybug has the step, next, and continue functions with the exact same functionality as pry, and same functionality as probably most other debugging tools that you have used. And bybug also allows you to backtrace your code leading up to the break. So perhaps the error didn't happen right away, but a few steps down the line you can backtrace your code to help you find the error. And you can also alter your code in real time to test functionality. So say you have an array of 5 numbers, and your function is supposed to add up the sum of the array. You can change your array from 1, 2, 3, 4, and 5 to 11, 12, 13, 14, and 15 in real time to test to make sure your function still works as intended. And then here's the works cited for some of the code and the ideas I talked about. Thank you.
Hi everyone, this is Group 5 and we'll be discussing Redux.JS. These are some topics that we'll cover in our presentation. We'll briefly introduce what Redux is, the motivation behind Redux, and when to use it. We'll also cover the core concepts and architecture, including actions, reducers, and store. And we'll show 2 examples to demonstrate how they work. What's Redux? It's a tiny library which is used to manage the predictable state for JavaScript web applications. Well, what's a predictable state? Basically, it's a store object which contains all of your states in one place. So this can be states for any one of your components, like the UI components or server responses. However, Redux won't let you change the states directly, but it's going to ask you to describe the changes in form of what's called an action, which is just a plain JavaScript object. Also, Redux is widely used in MVC-based web applications. This means Redux can be coupled with popular framework or libraries such as Angular, React, or Ember.JS. What's the motivation behind using Redux and why do you need to use it? First, state management is vital, especially in single-page web applications because the state of your components will depend on each other. So all of your components need to share the same state for your app to be consistent. As a web application grows, the number of states to be managed also grows, and things can get complex pretty quickly. Imagine a situation where your app is handling a bunch of state changes all at the same time, like data retrieval and hiding and loading web elements. Every addition to your app is an increase to the complexity of state management, and you'll likely lose track of what's really happening in your app. And this is what we call mutation and asynchronicity, and they're difficult to manage when your app is large. And this is where Redux becomes a useful tool.
We'll be going over a bit of the architecture of Redux. As we can see in the diagram on the right, Redux follows a unidirectional data flow architecture, which means that information does not backtrack between the different components. There are 4 main components we'll be going over in detail. Those are actions, dispatchers, reducers, and stores. Let's first go over actions. Actions are small payloads that briefly describe what has happened. So in the example below, we can see there are 2 parts to this action. We got the type, and we got the object of which the action was performed upon. So if we were to translate this object, we can say user2, or if we want to be more complete, Emily liked photo 52. Once we have the action, we can then call the dispatcher to trigger a state change. The dispatcher makes any needed API calls that are part of our program before handing off this information to the necessary reducers that will process these changes. The reducers called by the dispatcher takes 2 inputs, the action and the current state that is grabbed from the store. The reducer would then take these 2 pieces of information to generate the next state. Take note that reducers are pure functions, meaning that the same input will always create the same state. If we have multiple reducers in our application, these are all sent to the root reducer, which compiles everything into one state tree. So why would we use Redux over the model view controller designs that we're used to? Well, for small-scale projects, Redux actually might not be the better solution. Redux takes a lot longer to get set up compared to MVC. Also, with small-scale projects, we have fewer models and controllers, so getting them to work properly together is actually trivial. However, as soon as the scope of the project increases, with more models and controllers that can change each other's states, it's easy, if we're not careful, to lose control over who changed what, which makes debugging a lot harder. With MVC, states are mutable, meaning they can be changed, whereas for Redux, states are immutable, so every time we call a reducer, a new state will be generated, which means that in our store, we would have a historical archive of past states to go back to, should we need to undo something. Finally, with MVC, asynchronous calls creates uncertainty, because with the multiple models and controllers that are running concurrently changing each other's states, the same input the user puts in can generate different states at different times. Now back to reducers. As mentioned before, we can have multiple reducers in our program, each of which will generate its own output. We should then have a root reducer, which combines all these different outputs into a state tree that's saved to the store. This is then sent to the view layer for a UI update. This state tree is also used to generate the next state for the next action. So let's put everything together. We have an action that goes to the dispatcher. The dispatcher would then make all the necessary API calls it needs before sending it down to the reducer. The reducer takes the current state from the store to generate the next state. This next state is then stored in, well, the store, and is also sent to the view layer to update the UI for the user.
So, how do you decide when to use Redux? If you are just getting started with React, it might not be a good idea to use it because you might get even more confused with state management. If you already know JavaScript and React, all you need is a better understanding of state management before you can dive into Redux. And in general, Redux works well with larger scale applications where you have reasonable amounts of data changing over time. So if you think your app is small enough to do state management within its own scope, there is no need for Redux. And one final point, Redux is not a mandatory tool in your applications. It's just another tool you can use, and it's pretty handy.
Now let's go over some examples of Redux in action.
Let's go over a basic example that I built off of the React Redux app template. So here we have two child components, child 1 and child 2, and they're sharing the counter using the Redux store. So this is a pretty basic, straightforward counter that does what you expect. You can add, you can decrease, you can enter a custom amount you want to add. So for example, add 100, or even just minus. So the main thing here is that because they're sharing the counter, changing 1 in one child will get changed in the other child as well. So let's take a look at how it's done in the code. Alright, so this is the entry point into our app, Index.JS. This may look familiar because this is just React, and that's because Redux is a state container for JavaScript apps. So for this example, I'm using React. So everything here will be pretty much the same as what you would use in React, except for this line here and the closing tag for it, the provider. So this provider will provide our main app that's wrapped inside it, or the Redux store. So let's see what we have in store. So in our store we have a reducer, and if you recall, a reducer specifies how the application state changes in response to an action sent to the store. So let's see how we do this in counterslice. So in here we have our reducers again, and here we have 3. We have increment, which does +1, decrement -1, and we can increment by amount, which is plus whatever you sent. And then after that, we just need to export it. So we export the 3 reducers as well as our state.counter.value, which is the actual value of what that we're counting. And we also export the reducer itself. So let's see how this gets used in counter. So in counter, we just have our buttons here. So this is the increment value button, and when you click it, it dispatches the increment reducer. So dispatch basically triggers a state change. So similarly, in decrement, we dispatch the decrement function. And just like before, when you click on the increment by amount button, we dispatch the increment by amount, and you pass the number that the user entered. So this is just a counter variable. So let's see what we're actually using it in the app. So in our app, we just have child 1, child 2. In each child, we have the counter. So notice how we're not passing any information down from app to each child. Everything here from the counter is, all the information is taken from the Redux store. And that's how we're able to have both child 1 and child 2 share the same counter.
Okay, so hey guys, I'm going to show you an example of a Redux app that doesn't use React. You don't need to use React in your Redux app. I mean, it's nice to, it's kind of easy to, and it's kind of meant for it, but you're by no means required to use React when you're using Redux. So here I have a to-do list that's, built with just regular JavaScript. Not mine, I pulled it from some guy's GitHub. Shout out to that guy. Yeah, so I'm kind of going to go through everything, all the different Redux parts, and kind of show you how they all work together. So starting with the entry point of the app, we have the store. In Redux, it's kind of the whole point is having one store, one place, all your state, all that stuff. So we can, get the state, dispatch everything, handle the event listeners, do all that stuff here. And we need the reducers to do that. So what these reducer functions are, actually first, this is the initial state. I just added it, here, just to have stuff of just a thing we're going to be doing in the future. So we have these reducer functions, these pure functions. These are not mutating anything, not mutating the state. What they are doing, though, is creating a new state from an action as a response to an action, I guess you could say. And the only time that they're not creating a new state is if they're returning the old state. So they're never mutating it. There'll never be any side effects. So you're never going to be calling an API. You're never going to be calling any non-pure functions. So you're never going to be using like a random function or something like that. But yeah, so we got 3 different reducer functions. We can add, complete, and delete. And that seems to work just fine. So now this combined reducer function, it's kind of a design pattern to have all the reducers into one, that you can have one thing called a root reducer where you create the store from, which is quite nice. It's kind of all in one place. Let's take a look at these actions. So these are called action creator functions, and they just create an action. They just return an action, quite simple, get it ready for all dispatch. And what I like about this vanilla JavaScript example, why I'm showing it to you, is because you can see everything separated. If you're looking at a React app, like I have this shopping cart example here, there's a lot of boilerplate, and it's hard to tell what is Redux, what is React, because it's so, combined and meshed together. But here in the actions, you can see different action creators, the reducers, different, so you got different cases for different reducer pure functions, and and stuff like that. So that's why I like having this vanilla JavaScript example, because you can see the actions, you can see the reducers, you can see, the store being created, you can see the dispatching, you can see the listeners, you can see everything separated, so you can get a good understanding and a good grasp of what Redux actually does before you kind of dive into a big React application in a actual use case for Redux. But so you don't need to use React. You probably will, and you probably should. But so.
Hello everyone, we are Group 15. Today we are going to introduce one of powerful framework called Ember. We will introduce Ember through the following 4 points, which is introduction, core concepts, application development, and additional talk about advantage and disadvantage of Ember. Okay, so for introduction, I will talk about what is Ember, how to set up, write some code in template, and talk about what is root and what is Ember component. First of all, what is Ember? Ember is a JavaScript front-to-end framework designed to help you build websites with complex user interactions. It provides developers both with many features that are essentially manage complexity in web applications. So if you want to build a modern web applications, then Ember might be one of best options for you. So next, how to set up. You have to use npm to install Ember. If you are using Mac, you probably gonna add sudo in the front of npm because there is some problems on Mac that tell you don't have any permission to install. I have some problem before. And then after you install Ember, you can create a new application called by enter Ember new file name, and then enter that file, write some Ember serve in your terminal, and then with a couple of minutes, it will tell you build successfully, and then you can connect to the server. And when you connect to the server, you can see the welcome page. It tell you you made it. So we already set up the environment and connect to server. So next step is how we write our own code. We just create a new file by Ember. It's pretty good that Ember will automatically create a bunch of files like templates, roots, component, and style sheet in our file. So basically, in Ember, the HTML file are actually HBS files, and in root, root is templates application HBS. You can find it in your file that you just created. And the file is always rendered when the user loads the page. And there is an outlay. The outlay will replaced by other roots. We will talk about roots later. And so now let's write some code in template. Now we can show the local host. It's a welcome page. Now we delete it. We write our own code, such as header, which is Ember demo, same as HTML. It's pretty easy. And then add some paragraph. And you can see this. And when you save it, you can see your code is on here. And then let's define some roots. So if we want to build an application that show a list of scientists, to do that, the first step is create a root. So what is root? For now, you can think of roots as kind of different pages that make up your application. So Ember comes with generators that automate the code for common tasks. To create a route, you type Ember generate route and file name, and the Ember will give you some scientist JavaScript, and then in templates will give you a scientist HBS, which is HTML file, and then give you some test. Also, we will talk about test later. So after that, now we open the scientist HBS file, write some code like header list of scientists. Then we open the new page, which is localhost scientists, and you can see the result of here list of scientists. And then we open the scientist JavaScript, write some code like this. We will talk about the detail in core concept, but for now we can say there is a new person, some person, like we wanted a scientist. And then back to the scientist HBS file, it seemed like HTML, like you will list some the scientist. And then when you save it, it already rendered and you can see the new output here. So it's pretty useful. And next one, the components. The main idea is that as your application grows, you will notice that you are sharing UI elements between multiple pages or using them multiple times on the same page. So Ember makes it easier to refactor your templates into reusable components. So in shortly, the components are reusable parts of templates. And then for more detail of components and routes, we will talk in the core concept.
Good evening, everyone. This is Nan. I'm going to talk about the core concept of Ember.JS, and there's more detail in templates and routing. Let's first look on what is a template. Templates are HTML. Ember UI are HTML driven. Every part of the UI that is shown to the user is defined as an HTML template somewhere in your application. And the central template in the Ember application is the application.hbs file. And to style your application, you have to put all your CSS decoration into the app.css file. And let's look at an example of the application.hbs file on the right hand side. And you can see all the HTML tags are as shown, just like what we do as the normal HTML page. And let's look at the example when we put in all the CSS decoration into the app.css file. And as we can see, the home page will be changed with all the decoration applied to the home page we just make up with the template. As we can see, our application template are already decorated by the app.css file. And that is easy for developer to handle all the pages, since template can also working for HTML tag and Ember functions. But still, there are some restrictions in the Ember template. First, only valid HTML element in body tag can be used. That means if the tag is not applied in body tag, then you cannot use it into the template. And the second part is no script tags in template. So that means you cannot directly put your JavaScript file or JavaScript comment into the template file. Now let's take a look on routing. Consider you're having an application with a bunch of posts and you want to give each post a separate URL. Also, you may want to direct your user to the proper URL. And that's how routing works. Routing can render the template and also load up a module that is available in template and redirect to the new route and handling actions that involve changing a module or transition to new route. Here's the basic routes page. Let's take a look on the basic routes. As we can see here, map is the method for defining URL mapping. What it means is it will map the template to another URL the developer defines. And as an example here, the about template is mapped to the URL about, and favorites is mapped to faves. Now let's take a look back to the template. As I mentioned before, templates are HTML. In HTML page, we can use a tag for redirecting. In Ember.JS, we can use a tag called link to for navigate between routes. Let's take a look on the sample code on the right hand side. There are 3 link to tags, and inside the link to, there are add route attribute, which is indicating which template is being to redirect to. And the first link to, there's index. So once user clicking on the logo image, will be redirected to the index template, and also about and favorites doing the same thing. Let's talk more about routes. Nested route means there's a route inside another route. In such a case, you can imagine you're having a home page, and then you're going to one subpage, and inside a subpage, you're having another subpage. That is how nested route uses. The application route is for the first time your application load up, and this route will be show up. Index route is for the user using the URL with a slash. And you can map this index route as any template you use inside the mapping function with the path with only slash. Wildcard globally routes is for matching all the multiple routes. It catches all routes which are useful when user enter an incorrect URL and display all the route in the URL. From the template, if you want to change anything about routing, use link to tag. And in a route, you should use a function called transition to.
For application development, I'm going to talk about configuring your app and testing. config/environment.js. This file is where you configure your environments. Like other frameworks, Ember has different environments such as development, production, and test. For example, the configuration for the development environment will go into here. Ember CLI build.js. This is where you import things such as third-party libraries. This file will run when you build the app, when you run the Ember build. It will include everything you imported in this file into your build. For testing, Ember has QUnit and QUnit DOM. Which is a powerful, easy-to-use JavaScript unit testing framework. And the test in Ember is just very similar to the test in other frameworks or applications. To run the test, you will use Ember test or Ember T, which will run all the tests for you. So there are some cases you want to use Ember, and there are some cases you don't. When you want a single page web app, Ember is very good. So what is a single page web app? For example, I have a page right here, and when I click the links, you can see the URL is changing, but there's no request and response. It is because that what we are seeing is the index page, but the routes here, days/2, is handled by JavaScript. And this will cause a problem if the user just enter the URL instead of going through the index page. they will get page not found. This is because that we are requesting for the whole URL, but what we can provide is just the root index and let the JavaScript to handle the subroutes. So to deal with this problem, we will have to configure our web server, such as Nginx or Apache. If you're dealing with mostly static contents, Ember is a good choice. Such as, for example, if you are building a personal web page or a company description page, Ember is very good because it's very simple when you deal with the static contents. And if you are a user from Rails or some other framework that has the CLI, Ember may be very familiar to you because it has a decent CLI. And if you are dealing with database, Ember is not a good choice. You can use Ember to work with database, but you will need APIs or another backend framework. Compared to other frameworks that can deal with database easily, I just think that Ember is not a good choice when dealing with database. If you want to build a very large project, I don't think Ember is good because Ember relies on JavaScript heavily, so when the user load the page, it will be very slow. Like if the user load the index page, it will be very slow because every subroutes are in the JavaScript. So they have to load everything when they first visit the page.